right, there we go. Okay, so this is the very beginning of 4.4. You can see that I have the rest filled in, but again, there was a problem when I recorded, so we're going to do this together. What we're doing here in 4.4 is we're reviewing, we're graphing now. So we're taking our unit circle and now we're just putting it in the graph form. So you have your unit circle out with you. I'm just going to draw a little one like right here. And the only piece that I care about, and you don't have to draw this because you probably have your unit circle just like sitting next to you. The only piece that I care about that we're actually going to graph are the quadrant angles. So we care about 0, and we're going to graph these in radians. So I'm going to call this one pi over 2, pi, 3 pi over 2, and 2 pi. The x-axis of all of these graphs, so we're kind of going to do sine together, is going to be these angles. My x-axis is in terms of theta. So I'm going to label 0, 2 pi, pi, pi over 2, and 3 pi over 2. So like I told you, those are the only angles that I care about. Those are the ones we're always going to graph on the x-axis, and the x-axis is always going to be angles. On your unit circle, we know that the little points are, and I'm just filling this in because you already have it. At 0, 2 pi, it's 1, 0. At the top at pi over 2, it's 0, 1. Oh, that's messy. At pi, it's -1, 0. At 3 pi over 2, it's 0, -1. So those are points you already have, and that's literally what we're graphing. When we are talking about sine, we're talking about the y values. So I'm taking at each angle, I'm going to graph their y point. So at 0, 2 pi, my y is 0. So I'm going to graph 0 for my sine at the angle 0. At pi over 2, my y is 1. So I'm going to go as high as 1. We'll label the axes as 1 and -1. So I go as high as 1. For pi, we hit 0 because that's our sine at pi. At 3 pi over 2, we go as low as -1 because that's what sine is there. And then at 2 pi, we're back to the beginning, so we're at 0. So our sine graph looks like this wave. It goes through 0 at 0 pi and 2 pi, and then it goes to +1 at pi over 2 and -1 at 3 pi over 2. And we graphed the sine graph back when we did our BFF graphs. And I think the only thing I told you, I was like, you need to know that it's like wavy, but you also need to know that it goes through 0, 0. So we're just kind of proving that that's true. Off to the side, I've got this little A and then PER. So A is stands for amplitude. Amplitude means like how tall the graph is, and it cares about like from the middle to the highest point and then from the middle to the lowest point. So it is 1, it goes from 0 to 1 to go to the highest, and it goes from 0 to -1 to the lowest. So the amplitude, the height is 1. And that happens in every single sine graph that isn't transformed. Every normal sine graph, the amplitude is 1. The PER stands for the period. It's like how long does it take to do an entire sine graph? So the cool thing about sine and cosine is they're waves, so they're going to keep repeating. And so it takes a period of from 0 to 2 pi to get that entire period done. So I have to do from 0 to 2 pi to get my entire sine wave. And then after 2 pi, it will start repeating again. So my period here is 2 pi. Ooh, that is not what I wanted to do. The reason these things are important is because we're going to do transformations. That's kind of what all of 2.4 or 4.4 and 4.5 are. And so we need to see what like the basic sine graph looks like. We're going to do the same thing with cosine as well. It's like a wave just like sine. It's just essentially scooted over a little bit. We can graph the exact same way we did with the sine, except instead of looking at the y like we did with the sine, for cosine, we're looking at my x. I'm still using the same angle, so I'm going to go label my x-axis with those angles. I'm going to label it 0. I'll end at 2 pi. And again, this axis is theta. You don't have to write that. I just find that helpful to be like, oh, our x-axis is my angles. That's why we're using 2 pi, pi, pi over 2, 3 pi over 2. And I'm going to argue that the amplitude is the same. It still goes from +1 to -1. So I kind of like to just set myself up with that. amplitude is still 1, period is still 2 pi. It's the exact same thing as sine. Those are the exact same thing. And then I'm going to use the like little unit circle graph that I made below, but you can look at your unit circle because I'm just asking myself, okay, cosine at 0 is 1. So I'm going to go graph the point 1 on my graph. 0, 1 will be here. At pi over 2, my cosine, my x is 0. So my graphing point at pi over 2 is on the axis, it's at 0. At pi, my cosine is -1, so I'm going to go all the way down to -1. At 3 pi over 2, my cosine, my x is 0, so I'm going back through 0. And then at 2 pi, it's the same thing as it was at 0, so that's at 1. And then we're going to kind of try and make this look like it's a wave, just like the other pieces were. And that's what my cosine graph looks like. One thing I like to do, and I'm going to do this with a highlighter on the iPad, but I usually do it on paper pencil too, is I like to make kind of like a boundary of what my graph is. And when we do transformations, we'll make the boundary and then draw our sine and cosine. If you're using paper pencil, I usually do little like dash marks like this to kind of show like this is like the box I need to stay within. I call these like my boundaries, and that just helps me know that like my cosine or sine needs to fill the entire box. And like it must be contained in that box. So I'll draw like a little boundary over here too. So it goes as high and low as the amplitude, and it goes as far over as the period. Okay, doing okay so far? So this is like, now we're doing transformations, which you've done before with like quadratics with absolute values. I just had to like teach you what sine and cosine were. And so these 5 points are super important that we're going to use from now on. At the very top of the page, I want us to write this here. We're going to write y equals a times sine b x minus c plus d. And I've written that in like a different, like a very similar way, but a different way when we just did normal transformations. And they mean very similar things, but here we're dealing with it being sine or cosine. So it's just one of my trig functions. The first that I'm going to deal with, so the video that you'll watch later will have more, but we're going to focus mostly on A and B, and then we'll do a little bit with C later. So if you have a number out in front of your sine, like the problem we're going to do next is 2 sine theta or 2 sine x, which means that we're doing 2 times sine. That affects your y. You can think of that as a times y, and that affects your amplitude. It's a vertical stretch of your graph. So think about, instead of my amplitude being 1, now my amplitude is going to be 2. So it's going to be like longer and taller. And then also if A is negative, it's a flip. It flips my graph like up and down. While we're here, we'll also talk about what B does. So B affects your horizontal shift and like stretch and shrink. So I'll say horizontal. And what B does is to find like my new period or the new amount of time it takes me to do my sine or my cosine graph. We're going to say the new period is 2 pi divided by whatever B is. So B is not my period. It's not exactly how long it is. It's 2 pi divided by that number. And so we'll look at examples like that once we get there. Okay. So the first example we're going to do is y equals 2 sine theta. So I've got a 2 out front. I have nothing in front of my x. So the only thing that's changing right here is my amplitude. So my amplitude is normally 1. Now it's 2. That means instead of starting and stopping at +1 and -1, I have to go all the way up to +2 and down to -2 to do my whole graph. Since there's no number in front of x, there's no number between sine and x, that just means my period's the same. My period is 2 pi. So that means I need to label my x-axis to go from 0 to 2 pi. And that is what we like consider normal. So we're just going to set up kind of like our normal expectations, our normal angles that we care about. And once I have that, the only other thing I'm going to do is set up my boundaries. So I know that I have to go as high as 2. So I'm going to kind of draw like a dashed line, or in this case, I'm highlighting. I'm going to go as high as 2, and I'm going to go as low as -2. And I have to do the whole sine graph between 0 and 2 pi. So I'm putting kind of marks there. And again, this helps me know how like tall my graph should go, how wide it should go, how crunched or not crunched it should be. So I do these to kind of set a boundary to myself. And then once I have that, then we're just going to use the points that we know are sine to graph my sine graph. So it says sine, so I can kind of scroll back over to my original graph. The more of these we do, the more you'll kind of like already know what this is. But like in my head, I'm thinking, okay, sine goes through 0 at 0 pi and 2 pi. And then the second point is up. And then the fourth point is low. So those are what I'm going to go graph over here. So I go through 0 at 0 and at pi and at 2 pi, the first, the middle, and the last point. The second point goes to the highest point, and then the third point goes, or the fourth point goes to the very lowest point. And then I'm going to graph from here. All right, doing okay so far? Cool. All right, the next one is very simple to that. Oh, I'm going to erase this unit circle just because I don't need him anymore. This one, the only difference now is I'm doing a cosine graph. So I'm going to practice graphing cosine. And this time my amplitude is -3. Or not my amplitude, excuse me, my A is -3. I'm going to remind myself that my amplitude is never a negative number. My amplitude is just going to be 3. But since I have a negative, that just means I'm going to flip my graph. That just means instead of starting high and ending high like cosine normally does, we're going to start low and end low. And I have to go as high as +3 and as low as -3. There's no number in front of my x, so my period is still 2 pi. So I'm going to start by setting kind of my axes up. 1, 2, 3, 1, 2, 3. So I'm going as high as 3. I'm going as low as -3. We'll say 2 pi is here. You can make 2 pi wherever you want it. There's 2 pi, here's 1 pi, here's pi over 2, here's 3 pi over 2, and here's 0. And I need to go from 0 to 2 pi. And like we said, since it's negative, instead of starting high, I'm going to zoom out just so we can look at cosine. So cosine's pattern is it starts and ends at the highest point, and its middle is the lowest point. So I'm just going to flip that. So my highest points is now going to be in the middle. And then the 2 points that were starting high are going to start low. It's just kind of opposite of what I was doing. So I'm starting low, I'm ending low. My middle point is the highest. And then the other two just go through the middle of the graph, go through 0, 0. And then we just try and make it look kind of loopy. So the negative flipped it, the 3 just kind of stretched it, and we haven't done a period change, but that's what we're going to do next. So I just have 2 more examples that we have to do. All right. Letter E looks a lot like the one we did on letter C. It's still 2 times sine, so that 2 is still going to affect my amplitude. The second 2, though, affects the period, and we haven't dealt with that yet. So the second 2, the 2 between the sine and the x, that's my B. And like we said up here, P equals, my new period equals 2 pi divided by B. So I'm going to just zoom in over here just so I can write kind of nicely. My period is now 2 pi divided by 2. 2 pi divided by 2 is just pi. So that means instead of having like 2 pi as a distance that I need to get in between, I'm going to do half of that. I'm only doing pi. So I'm going to be a little dramatic about how I label this graph. So instead of going from 0 to 2 pi, we're going to just go to pi. So that means my distance is half of what it was. So it's just going to be like a little compressed, a little bit scrunched up. My amplitude is 2, so I still have to go as high as +2 and as low as -2. So I'll go label those. And then on all the other graphs, we labeled the points in the middle. So I have to kind of decide what my new points in the middle are. Since I'm not going to 2 pi, I'm only going to pi. halfway between 0 and pi is pi over 2. So that point's important. We care about the first, the middle, the first, the last, and the middle. And then I want the next two middle points. So my next thought is, okay, what's halfway between 0 and pi over 2? I would argue fractions are our worst thing in this class, which is okay. But I'm essentially thinking what's halfway between 0 and 1/2. And we know that that's 1/4. So pi over 4 is like the next mark I'm going to make. Similarly, I'm going to ask myself what's between 1/2 and 1/2. So what's between pi over 2 and pi? And that's just adding another fourth over there. So that's 3/4 pi, or 3 pi over 4. You okay with that so far? Perfect. Okay, I just drew the rest of my boundaries. And the boundaries, again, just help me know I'm going to have to do my whole sine graph in here. We remember that sine goes through the middle at the very first angle, the middle angle, and the last angle. It's not a negative sign, it's a normal sign. So it's going to start by going up to the highest point, and the second to last point is the lowest point. Once you have all your points, just kind of wave it on through. And that's my sine. You can kind of see, compared to the one above it, it's a little bit more scrunched than the 2 sine of x, because it's 2 sine 2x. So it's scrunched up a little bit. Okay, the last problem we're going to do is letter F, and it says y equals 3 sine 2 times x minus pi over 4. This pi minus pi over 4 is my c. So we haven't talked about c yet, but c is a horizontal shift. It's where I'm moving left or right. Oh, I ran out of space. That's good enough. The one thing I do like to remind myself is I'm moving left or right, and it's opposite of what I think. So I think left should be negative, but it's actually a positive number. So if it's x plus something, then I'm moving it to the left. And if it's negative, if it's x minus a number, I'm going to move it to the right. And again, we've done that with quadratics. We're probably like, oh yeah, that makes sense. I mentioned this in the other video, but I can mention it while we're here too. D is a vertical shift, so I'm moving up or down, and that's exactly what we think it should be. So if I have a plus or minus, which we're not going to do any of those in this video, the next video has that. If it's plus something, it moves it up. If it's minus something, it moves it down. All right, so let's go look at the last problem we're going to do. I'm going to identify all the pieces that I have. So the first thing I identify is that I have 3 sine, and we know that that 3 affects my amplitude. So that means I have to go as high as +3 and as low as -3. The 2 is my b, and that affects my period. So my new period is 2 pi divided by 2. And when you do 2 pi divided by 2, that's the same thing as pi. So just like the last one, we have only between 0 and pi to get this through. The only difference now is I have x minus pi over 4. And so that means I'm going to go to the right pi over 4 units. So that means I'm not starting at 0. I'm actually starting at pi over 4. Okay. Now, normally I get on here and label like 0 to pi, but we're not going to go from 0 to pi. We're going from pi over 4 to something past pi. I essentially need to add pi over 4 to pi to figure out what my new mark is going to be. So this is where we kind of struggled the other day in class. I think it's easiest to think, okay, well, if I was at 0 and now I'm plus pi over 4, I was going to pi, I was going to be at pi units, but I'm going to add pi over 4 to show that I moved right pi over 4. So pi plus pi over 4, if we remember our fractions, and again, we can take the pi's away, we can just make it 1 plus 1 over 4. We know 1 is the same thing as 4 over 4 plus 1 over 4. I had to get like denominators in order to add them together, but now I can add them together. 4 plus 1 is 5. So 1 pi plus pi over 4 is the same thing as 5 pi over 4. So that's where I'm going to be right here. In order to find the other points, you can do this one of two ways. One way I thought about was like, okay, if we're going to be a total of pi units, halfway between my pi over 4 and 5 pi over 4 would be like doing like 3 or 2 jumps into the middle, 2 pi over 4 jumps into the middle. Another way I was thinking about it in a different class is like if my middle would have been like pi over 2, then I want to add pi over 4 to get to like my new middle. So just like my middle, I'll go back over here. Like when I changed my period to be a pi units, so like this whole distance was pi, my new middle was this pi over 2. So I need to move, just like we moved our pi over 4, I'm going to move my pi over 2 a pi over 4 over as well. I'm essentially just showing that I'm moving a fourth over, a fourth over, a fourth over. What happens in this example is that all of these are plus pi over 4 distance away from each other. And that's why I tried to do this example, because like pi over 4 is plus a pi over 4 to get to 1/2. So like 1/4 plus 1/4 is 1/2, et cetera, et cetera. That just leaves this middle point is going to be 3 pi over 4. And again, if you want me to explain more on that, like I said, I could have taken, I knew my middle would have been this pi over 2. So if I want to move that over a pi over 4, pi over 2 plus pi over 4, I'd have to just get like denominators. So I'd have to multiply that by 2. So I get 2 pi over 4 plus pi over 4, which gives me 3 pi over 4. And so that's how I know my new middle is 3 pi over 4.
So whatever the first one is, pi over 4, that's what you're adding to all of them.
That is what I'm adding because the period is pi. If the period was not pi, I wouldn't necessarily add that. But since the whole period is pi, that means like a fourth of that is like what all my marks are going to be. So that just means I can add a pi over 4 each time. We'll do more examples in the other video. And so that might help kind of explain why we do or don't add something each time. But this one just worked out nicely that I was adding pi over 4 each time. Oh no, I want some of those up. Okay, I erased too much. Let me do this again. I think the best way to think about it is I knew that I had to go from 0 to pi over 4. So I knew that I had to add pi over 4 the first time. I had to add 1/4. And I would have been at pi, but we moved over a pi over 4 to show that I moved everything right pi over 4. And the middle, if I was at pi, if I would have stayed at 0 and pi, my middle would have been pi over 2. So when I moved my 2 endpoints over a pi over 4, I had to move my middle pi over 2 over a pi over 4 as well. And then once I had done enough of that math, I was like, oh, all of these are just pi over 4 away from each other. Does that make enough sense for right now? Okay, great. We are going to do our amplitude and then we're going to graph, and then I think we're done. So the hardest part is labeling this axis. So that's why I wanted us to kind of learn all of this today. So the next class, we can spend more time kind of reviewing these axes. But I'm going to go my amplitude 3 and -3. I like to do my boundaries so I know where to get my graph in. And I'm reminding myself it's a sine graph, so I have to graph sine. So sine always goes through the middle at the first, the middle, and the last angle. It starts by going high and it ends by going low. So it's going to look something like this. Okay, so that is all that we did. Everything else is in the next video of the notes. I skipped a couple problems here and there, but hopefully that kind of works through the rest with you.
Okay.